Alright, this is the video lesson for solving systems of equations using substitution. Up here, substitution. And this is part 2 of the video where we're going to be dealing with all story problems. So, let's first read the directions for these story problems, and in the directions it says, read each of the following problems carefully. That's key, to read the problem carefully. Then it wants you to define the variables, write a system of equations, and solve each problem. So really you're looking at 4 things here if you include reading it carefully, which is something you definitely need to do. So let's read problem 1 here. It says Rihanna is older than Ken, and it says the difference of their ages is 12 and the sum of their ages is 50. Find each age. So first thing we need to do here after reading the problem carefully is to define the variables. And again, defining the variables is simply telling me what does your x variable represent, what does your y variable represent. And as we've said for all story problems, the way you figure out what your variables represent is you ask yourself 2 questions. One question is, what is it that I do not know in this story problem? And the other question is what are they asking me to find? And most times the answer to those 2 questions will be the same. And that will be what your variables are. So in this problem, the thing that you do not know is you do not know Rihanna's age or Ken's age. And what they're asking you to find is their ages. So again, like I said, it goes together just like that. So for variable x, we're going to say this is Rihanna's age, and you could also say that this is how old Rihanna is, but that means the same thing, and y is Ken's age. Alright, so done with part 1, which is defining the variables, and again that part will be graded. Did you write down what your variables represent? Part 2 then is to write a system of equations, and we'll write the system based on what the problem says. And the problem says Rihanna is older than Ken. Okay. The difference, now difference is a key word there because difference means subtraction. So the difference of their ages is 12. Well, if difference is subtraction, and it says the difference of their ages is 12, is means equals, so you must have a subtraction problem here that equals 12. Well, that subtraction problem is just simply Rihanna's age minus Ken's age. Rihanna's older, so you take Rihanna's age, you subtract Ken's age, and you're going to get 12. Like they said, the difference of their ages is 12. So there's equation 1. Equation 2 then is where it says the sum of their ages is 50. Well, we know again that sum means addition, so if you add their ages together, you're going to get 50. So there are the 2 equations you're going to use. Simple as that. Now, next step will be to solve each problem. And in order to do this, we're going to use substitution. Now remember, in substitution, in order to solve, you need to solve one of the equations for a single variable. Now, I'm going to pick this first equation here, and in this first equation, I'm going to solve it for x. And in order to do that, I'm going to add y to both sides. So I add y to both sides. This first equation turns into x equals y plus 12, or 12 plus y, either one would be fine. So I've now changed my first equation into that. So I'm going to kind of mark this first equation out now, because this now is my first equation. And now that I have this equation solved, I can use substitution, because if x is equal to y plus 12, I can now take that y plus 12 and plug it into this other equation for x in place of x, because I'm saying that x is no longer x. I'm now saying that x is y plus 12. So I'm going to rewrite my second equation, and I'm going to do this over here to the far right. So my second equation here, I'm going to say, let's see, I'm just trying to find a place to write this at. I'll just take that line out. So this equation, instead of x plus y, is going to be y plus 12 plus y equals 50. And now I continue to solve that. On the same side of the equal sign, I have a y plus a y. So I'm now going to have 2y plus 12 equals 50. And now you're just down to a basic solving equation. Subtract 12 on both sides. 2y equals 50 minus 12 would be what, 38? And then divide both sides by 2. So y equals 19. So there is one of your answers, y equals 19, which means that Ken's age is what? Ken's age is 19, right? Because, let me erase this check mark that I have over here. Ken's age is 19 because Ken's age was the y age. And then we just plug that number into one of your equations. I'm going to pick this equation right here, which says x plus y equals 50, and I'm going to solve it. And it's going to say, I guess I can do this up kind of at the top here. So I plugged 19 into this equation, and I'm going to come up here and I'm going to say x plus 19 equals 50. And in order to solve that, you subtract 19 on both sides, and x equals 31. So there's your second answer. Now again, you still have to write these in a full sentence, and that full sentence would be, and again I've run out of room here, so we're using all over the place. Let's go up here in the top right hand corner, and we're going to say Ken is 19 years old and Rihanna is 31. Done. So there, you've done all parts of story problem number 1. And I wrote that a little bit big everywhere, so we're going to do this problem number 2 a little bit smaller, so you have more room to show your work and everything. But that's pretty much how all these problems go. That same process each time. So let's go ahead and look at the next problem. And again, I'm going to start out a little bit smaller this time. So we're going to start out right here, and we're going to say, what does x represent and what does y represent? So we read the problem. At the end of the 2000-2001 football season, 31 Super Bowl games had been played with the current 2 football leagues, the American Football League, the AFC, and the National Football League, the NFC. The NFC won 5 more games than the AFC. How many games did each conference win? So, again, what am I trying to find, or what don't I know? Well, I don't know how many games each conference won. So x is going to be how many games did the AFC win, and y is going to be how many games the NFC won. And again, this is dealing with the 2000 to 2001 football season. You could add that to your sentence if you really wanted to. But those are my two variables. So now I'm going to set up my two equations, and I'll do that right below these two variables. So the first sentence there says 31 Super Bowl games had been played with the current two football leagues. Oh, that's another thing we might add to our things. It's not really how many games did they win, but it's how many Super Bowls have they won. So you might change that in your description. The final question asks how many games did each conference win. Again, Super Bowl games is what it's actually asking for. So anyhow, it says 31 Super Bowl games had been won. Well, 31 games had been won between the two conferences. So in other words, if you take X, the number of games the AFC won, plus Y, the number of games the NFC won, that will give you 31. That'll equal 31 because that's how many total games there were. So that's equation 1. I'll put a little 1 next to that. And then equation 2, let's see, it says the NFC, this is the last sentence there, won 5 more games than the AFC. Now this is one that causes some people problems. The NFC won more games, okay? The NFC is our variable Y, so they have won more games. So the number of games they won is going to equal the number of games the AFC won plus 5. So hopefully that makes sense because, again, the NFC won more games. The NFC won 5 more games. The NFC's variable is Y, so they won a certain amount of games, and in order to say that these two things are equal, you would have to add 5 to how many games the AFC won. So there are your two equations, and again, we're going to use substitution to solve now. So the second equation is already solved for a variable. It already says Y equals. This is what Y equals that I'm putting in parentheses. Y is equal to X plus 5, so I'm going to plug that X plus 5 in place of Y in the other equation. So now I'm going to come up here, right here, and I'm going to rewrite my second equation, or actually I'm going to rewrite my first equation, and it's going to say X, but instead of plus Y, it's going to say plus X plus 5. Now I put it in parentheses just because it was originally in parentheses, but you don't really need the parentheses since it's all addition. So X plus 5 equals 31. X plus X is 2X. So we have 2X plus 5 equals 31. We will subtract 5 on both sides. So 2X equals 26. And last step, divide by 2. So X equals 13. And that is one of your answers. That tells you that X, who was X? X was the AFC. That tells you that the AFC won 13 games, or 13 Super Bowls. And Y then, to figure out Y, you just simply plug that X that you got back into either of the two equations. You can plug it in right there, or you can plug it in right there. I'm going to pick the first one here. So in this first equation, I'm going to say Y equals 13 plus 5, so obviously Y equals 18, and so that means that the NFC won 18 games. Now again, you got to write this in a full sentence. I'm going to write this over to the side, so I should say the AFC won 13 Super Bowl games, period, and the NFC or I guess I didn't need a period there, maybe just a comma, and the NFC won 18. And you could say 18 Super Bowl games too, but that's kind of repetitive. So the AFC won 13 Super Bowl games, and the NFC won 18 by the end of the 2000-2001 football season. All right, so there's the first two. Two more to go, and at this point you really should probably pause and try the next two on your own. They should set up pretty similar to the first two. The process is definitely the exact same. So take a minute and attempt these on your own. Alright, and we're back, and for problem number 3 you should have figured out that X is going to represent the number of adult tickets and Y is the number of children tickets the family purchased. So there's your two setups, your two defining the variables. Now for the two equations, and if it says movie tickets are $8 for adults and $5 for children, a family purchases 10 tickets for $68 total. Within those two sentences there are two equations. The first equation I think everybody is pretty good at, and that is 8x plus 5y equals 68, because they bought X is the number of adult tickets they bought, which they had to pay $8 for, so 8 times however many adult tickets they bought plus 5 times however many children tickets they bought is going to equal $68, because that's how much they spent. The other equation is the one that kind of trips people up, and it's actually the easier equation, and that is simply the actual number of tickets. X is the number of adult tickets they bought, and if you take the number of adult tickets they bought plus the number of child tickets they bought, so X plus Y, that has to equal 10, because they only bought 10 tickets. So again, there's your two equations. You need to solve one of these equations for a variable, any variable, so that you can use substitution. So for for the second equation, I'm going to subtract y again and solve this equation for x. So it's going to say x equals 10 minus y. And again, you could have solved for any variable you wanted. You might not have done this the exact same way I did, but if you did it correctly, you'll get the same answer I do. So, second equation, I've solved for y, or for x, and it says x equals 10 minus y. So I'm going to simply plug that 10 minus y in for x, and I'm going to rewrite my second equation. And my second equation is going to say 8 times 10 minus y plus 5y equals 68. And all you did was rewrote that equation, but instead of writing x, you wrote 10 minus y, because 10 minus y is what x is. So here's your equation. To solve this equation, you're going to simply solve for y. So I'm going to distribute my 8, and I'll get 80 minus 8y plus 5y equals 68. Negative 8y plus 5y is going to give me 80 minus 3y equals 68. At this point I would subtract 80 on both sides. Running out of room here, but you'll see over here to the side I got negative 3y equals 60 minus 80 is, or 68 minus 80 is what? Negative 12. So negative 3 equals, or negative 3y equals negative 12. Divide both sides by negative 3, and y equals 4. And be careful with your signs here, because you're obviously never going to get a negative answer. Y equals 4, meaning that they bought 4 child tickets. They could not have bought negative 4 child tickets or negative child tickets at all. So If we know y is 4, I can go back to any of my equations and figure out what x is. Now, I'm going to pick an easy one here, and I'm going to go back to the second equation that we made, x equals 10 minus y, because now that says x equals 10 minus 4, so x equals 6, which means they must have bought 6 adult tickets. And again, you'll write this out in a full sentence, and again, any full sentence that is correctly written and has the correct answers, I'm going to write there were 4 child tickets and 6 adult tickets purchased. Done. Alright, and last problem. And again, I already gave you time. You should have already attempted this on your own, so we're going to go right into the solving of it. If you notice, if you've been paying attention in class, we actually already did this problem. We did this problem in Unit 6 where we solved it and graphed it. And again, it's the same principle here. It's just you don't have to graph anymore because you can solve it algebraically. But we're talking about reams of paper and boxes of crayons. So hopefully you figured out that X is going to be the cost of each box of crayons, and that Y is going to be the cost of each ream of paper. And again, this is the exact problem we did in the last section. Our equations are even going to be the exact same. The equations are going to be 1x plus 5y equals 54, because they bought 1 box of crayons, 5 reams of paper, and it cost them $54. And the other equation is going to be 3x, 3 boxes of crayons, plus, oh no, sorry, not 3, 5x, 5 boxes of crayons, plus 3y, 3 reams of paper, and that cost them $50, or cost this girl who's buying this stuff. So, same type of problem, should get the same answer if you happen to remember what it was. But we're going to do this using substitution. So, using substitution, I'm going to solve this equation for this x, because it's a 1x all by itself. And we'll do that by subtracting 5y. So I get x equals negative 5y plus 54. I then take this negative 5y plus 54, which is what I know x is now. X is that. And I'm going to take that and I'm going to plug it into the other equation in place of x. So the other equation now reads 5 times negative 5y plus 54 plus 3y equals 50. So, next step is to solve. I'm going to distribute the 5. I'm going to get negative 25y. I need a calculator now. Plus 54. 5 times 54 is going to be what? Plus 270 plus 3y equals 50. And continuing to solve, negative 25y plus 3y is negative 22y plus 270 equals 50. Then I subtract 270 on both sides. So I'm going to have negative 22y equals negative 220. which is going to come out nice and even. Divide both sides by -2 or 22, and you get y equals +10. So y equals +10, meaning the reams of paper cost $10 each. Again, take that information you know, plug it back into one of your original equations. So maybe I use the, let's see, maybe the second equation here. Plug it into that y and rewrite this equation as 5x plus 3 times 10 equals 50. So 5x plus 30 equals 50. Subtract 30 on both sides. 5x equals 20. And finally divide by 5, and x equals 4. Again, meaning each box of crayons was $4. And finally, you write this out as a full sentence. So, right there you have it. A box of crayons is $4, and a ream of paper is $10. Done. And that's all for story problems. There you go.